Okay, so the bunnies versus viruses page. Was anybody able to find the pattern with the bunnies? How are we?
Adding by 2.
Adding by 2 every single time. So the next number would be what? 12 and then 14. 6, 14. Okay, what about the viruses? Multiplying by 2. So 16 increases to 32 and then 64. Okay, so what are the similarities between the two? No, they're not. The what?
The 3, 8.
What else? Keep thinking. They're both increasing. Thank you. Now, they're both increasing differently. What's the difference between the bunnies and then the viruses?
Adding 2 and multiplying by 2.
You said increasing for something else? One of them is adding 2, one of them is multiplying by 2. Now, we've talked about the difference of adding 2 every single time and multiplying by 2. If you're adding the same number every single time, what's going to happen? It creates a straight line. But if you're multiplying by 2, it curves. Correct. It never ends with the absence of.
Why is the
I know he is. So the bunnies will be what type of function? Linear. Grab a laptop. You can. So the number of bunnies is increased by what?
2.
By doing what operation? Adding.
What just happened?
You add 2 bunnies. Why are we out of our seats, Eva?
I think it's locked, miss.
Turn it. It's not locked. I don't have a key. Adding 2 bunnies what? Every month. Now, every is a word that we use for what? To describe? Think linear.
Why?
What number goes with x?
0.
Word, not variable.
Range.
If you're adding each, every, per month. Each, every, per. We use these 3 words to describe what in a word problem?
Multiplication.
Starts with S.
Subtraction.
Slope. Slope is a word that's only associated with linear functions. You cannot, boys, you cannot find the slope of a quadratic function, you cannot find the slope of a parabola, and you cannot find the slope of an exponential function. You cannot find the slope of a curve. Okay? So the recursive rule means to apply the same rule to obtain your next result. We started with how many bunnies?
2.
2 bunnies. And if we started with 2 bunnies, that represents my y-intercept. Okay? The next thing, what did you do to the previous term to get to the next? You add 2. Okay? Now, you write your linear functions in slope-intercept form, mx plus b. We know that b is the y-intercept, so that would be my plus 2. And we just said that we're adding 2 every single time, so if we add 2 every single time, that would be my slope, 2x plus 2. Now we plot our points. When we plot our points, we should see what type of line. Straight line. Okay. Now look at the viruses. Since we're multiplying by 2 every single time, this is going to create what type of function?
Exponential.
Oh, it's
And we know that the number of viruses increased by doing what?
Multiplying.
Multiplying. By 2 viruses every day. Yeah, a day. 32, 64. Okay. So that means we started with how many viruses? We started with 1 virus and then multiplied by 2. Now, the equation for an exponential function is y is equal to a times b to the power of x. A is your initial value, which is 1. B is the factor, the number that we're multiplying by every single time, which is 2. We're doubling. When I graph this one, I should end up with a what? Curve. Did I do that right? 3?
the y-intercept is on 2 and it should be 1.
Oh yeah, I did it wrong. Okay. So 0, 1, 1, 2. I knew I was off by something.
Oh man, it's crazy.
Well, that is crazy.
Not so difficult now, are you?
Oh my gosh.
Brantley, are you calling me dumb?
Yeah.
Oh my.
Brantley!
It's a joke.
Anyway. What?
Would that be right?
That's not your, no. What option are you supposed to use? Did you type it in correctly? All right, so arithmetic and geometric sequences is just another word for a pattern, okay? But one of them is going to be exponential, the other one, oh no, yeah. You just did it in decimal form, but put the 5 in parentheses. Today we're going to work with arithmetic sequences. Tomorrow we will do geometric. Arithmetic, adding, okay? So arithmetic sequences are the ones where you're going to add every single time to find your next number. Now, patterns are something that you've seen throughout your childhood. You've been given but you've only seen it in this form. Given a set of numbers, you try to figure out how to get the next one, right? But obviously, with algebra comes formulas. So there are going to be a couple of formulas that you're going to learn. There's going to be another variable that you're also going to learn. Now, to get from 5 to 10, 15, what do you do every time? Add 5. That is known as your common difference, these plus 5s, because that is what you are adding every single time to get from one value to the next. And that's going to be variable D. Okay? Now, every number in a pattern has a place value. The number 5 is the first number in the sequence. The number 10 is the second number in the sequence, 15, third, 24th, and so forth, right? These first, second, third, fourth, those place values in your sequence, those are your X values, okay? But in sequences, they use the variable n. If you look at your, let's turn over to our calculators real quick. You're not actually going to do anything with the calculator. But look at the button that you use for x. Everybody see that n right there? That's because they're the same thing. Okay? So with these types of problems, they'll probably ask you, what is the 20th term in the sequence? They're just asking you, what if x is 20, what's the y value? What is the 20th place in the pattern? Okay? But anyway, so since that is the first term, our y-intercept, we know that to get our y-intercept, the x value must be what? To get your y-intercept, the x value must be 0. So to go backwards from 1 to 0, what do? Subtract 1. Now if we go backwards, and you're going to notice a mistake, to go backwards, instead of adding 5, what do? And if you subtract 5, you're supposed to get 0, not -1. That's typo. Okay? Typo. Yeah. Now, with arithmetic and geometric sequences, there's two different ways of writing the formula. I'm going to put a star next to explicit because that's the one that we're going to use. Explicit, the explicit formula, the way we write it, it looks intimidating, but it's not. This one's actually the one we're going to use because it's a lot easier to plug numbers into this formula. Okay? Recursive formula, not so much. It's easy to write, but not easy to use to find the 20th term, to find the 30th term in the pattern, okay? Flip it over to the back. Part A is asking us to tell whether each sequence is arithmetic or not. If it is, state the common difference, write the next term in the sequence. First, tell me, is it an arithmetic sequence, yes or no? Look at number 1. You know your strengths. If you're not strong, or if negative numbers are one of your weaknesses, start with the positive numbers, okay? How do you get from 1 to 5? Adding what?
4.
Adding 4. How do you get from 5 to 9?
4.
Plus 4. So to get from -7 to -3? Plus 4. Is this an arithmetic sequence? Yes, because we're adding what? 4 every time. That is my value of D. Okay? Now the next term in the sequence is going to be the 6th term. Okay?
13.
The 6th term is 13. That means that the number 13 is in the 6th place in my sequence, in my pattern. The way you would write this result, Seba, is to write it as A sub 6 equals 13. This tells you that the 6th term is 13. You don't actually put this part into the calculator, okay? With a little bit of practice, you'll get the hang of it, okay? So, number 2. Is this an arithmetic sequence? What do you add to get from 5 to 22?
17.
Plus 17. To get from 22 to 39? And 39 to 56. Okay, so is this an arithmetic sequence?
Yes.
Yes, the common difference, my value of D is
D equals 17.
17. Okay? Now, the next term, my 5th term, known as A sub 5, will be what?
73.
73. If I add another 17, I get 73. Understand? Okay? Number 3. What do I add to get from 8 to 9?
1,
Plus 1. 9 to 11.
2,
11 to 14.
3.
So is this an arithmetic sequence?
No.
Even though you see a pattern, this is not an arithmetic sequence because you are not adding the same number. It's not the common. It's not consistent, right?
So there's no common difference.
There is no. No, that's it. This one's a no, and we move on. Number 4. How do we get from 19 to 12? 12 to 5? 5 to -2? So is this an arithmetic sequence?
Yes.
Yes, the common difference is
Negative.
-7. You're adding a -7 or you're subtracting 7. And the sixth term in this sequence is
Negative 16.
Oh, wait. Oh, yeah.
Negative
I was thinking
16.
about that.
-16. Yes. Questions so far?
No.
All right. The second part is to write a function for each sequence in explicit and recursive form. Okay? It is confusing at first, but with a little bit of practice, I promise you'll get the hang of it. All right, number 1. Part A is asking us for a sub 1. So what are they asking us for?
The first one.
The first number in the sequence, which is
Negative 11.
-11. Easy peasy. D is the number that you're adding. So to get from -11 to -6,
5.
plus 5, plus 5, plus 5. So that is D. Now, to write an equation in explicit form, we're going to need a little bit more space than that. Ready? I'm going to come down here. You have the formula written on the other side of the page, but I'm going to write it one more time so you don't have to flip back and forth.
This was yesterday?
2 days ago.
I was here 2 days. Wait, on Tuesday?
You were gone for 2 days. You
I
left. No, you.
I wasn't here Monday. I was here that day. I was here Tuesday, and I left.
You were here.
early.
You weren't here for that.
This was Tuesday, right?
That
I was here for
yesterday.
this. I was here for this. That's why I was
No, you went.
I
You
left
left early, didn't you?
on Wednesday.
I thought you were gone for 2 days.
Yeah, on Monday I wasn't here, but on Tuesday I returned. On Monday I was out for a track meet. On Tuesday I was here. On Wednesday I was sick. This is why I know this.
Okay, so did you ever watch the other one, Mondays?
Mondays? Oh, no.
You didn't watch that video. Okay, so work on that one. Do you have the papers? Check and see if you have the papers.
Man, his computer's still loading.
Yeah, my computer's still loading.
Are you serious?
Yeah.
Welcome to the candy shop.
All right. As confusing as this formula looks, there are only 2 spots where you're going to plug numbers in. We looked for a sub 1 and we looked for D. That's the only spot where you're going to plug numbers in. Okay? So what was our first term in the sequence?
Negative 11.
-11 plus n minus 1, and our common difference was
5.
5. Now, to write this in explicit form, you must simplify it. So to simplify it, you're going to distribute that 5 backwards. Okay? Bring down the -11. 5 times n is 5 times -1,
Negative 5.
-5. You have 3 terms. 2 of them can be combined. 2 of them are like terms. Which ones are they?
Negative 11 and negative 5.
-11, -5. I'm going to bring down 5n. -11 minus 5 is
Negative 16.
-16. So the explicit formula for this example is a sub n is equal to 5n minus 16. Now, if they ask you for the 20th or the 30th number in the pattern, all you have to do is plug it in right there. Easy peasy. Okay? Recursive form. We are going to write that. That will not come up in your assignment. But recursive formula is a sub n is equal to a n minus 1 plus. The only spot you plug a number in is right there, D. That's it. A n minus 1 represents the number that comes before the one you're looking for. That's why we don't use recursive, okay? Because it's a lot more difficult to use, okay? All right, so a sub n is equal to a n minus 1, and what was D?
5.
Plus 5. That's it. Part E. Part E is asking us to find the what term? Sixth term, meaning that my value of n is 6. So I plug in a 6 where I see what? An n. So 5 times 6 minus 16. What do you get? 14. Okay. Bless you. Ready? Okay. Number 2. What is the first term in the sequence? 4. Take it from 4 to 13. Plus 9. 13 to 22.
9.
Plus 9. So those numbers are what? D. My common difference. Those are the numbers that I need to plug into my formula. We get a sub n equals, what is my first term again?
4.
4 plus n minus 1 times 9. To simplify, we distribute first. Bring down the 4. 9 times n.
9n.
9 times negative 1.
-9.
Negative 9. And then combine
9n.
4 and negative 9. So we get 9n
9n minus 5.
minus 5. Okay. To write this equation in recursive form, a sub n equals a n minus 1. Then what? Yep, plus 9, your common difference. All right, a sub 7 is asking us to find the 7th term, or plug in a 7 where you see the n. So 9 times 7 minus 5. What do you get?
58.
Don't say 53.
58.
58.
No, I heard some 53s back there somewhere.
Shane said 57.
Oh, Lord. Well, you know what Miss Lovelace is going to say. Put it in the calculator. Because apparently we can't do math in our head. No, you put decreasing, not decrease. Okay, how do you get from 8 to 6?
Minus 2.
6 to 4?
Minus 2
So our value of D,
is -2.
negative 2. What is A1?
8.
8. Okay? So let's plug in our numbers. A sub n is equal to what? 8 plus
n minus 1
n minus 1 times
-2.
times negative 2. To simplify, the first step is to distribute. So bring down the 8. Negative 2 times n.
-2n.
And negative 2 times negative 1. Positive 2. Then you combine
8 and 2.
8 and 2.
So 2n plus 10.
2n plus 10?
Negative 2n plus 10.
Okay.
Yeah. Careful with those negatives. Negative 2n plus 10.
Oh man, it's crazy.
To write it in recursive form,
an equals a n minus 1 plus minus 2.
minus 2. Good. A to the a sub 8 is asking us to find the
8 term.
8th term in the sequence. So we plug the 8 where we see n.
-6.
So you get -6. Yes, those are easy numbers to find, but like I said, they could ask you to find the 50th term, okay? So don't get too excited about that part.